Hello and welcome to today's GSA Hot Topic webinar. In the next 30 minutes or so, our research team led by Jordan here will take a comprehensive look at the continuing emergence of 5G Advanced, its benefits, momentum and the ecosystem support behind it. The on-demand recording of this session will be shared with you immediately following the live event. You can also download the presentation at any time by moving your mouse over the screen. You'll see a little download icon. And we'll also share a link to the full report with you immediately following the webinar as well. There will be time for questions following the presentation, which itself will be about 15 minutes. So if you do have any questions, please do submit them as we go along using the Q&A function you'll see on the right-hand side of your screen. We'll answer as many as we can during the event. Any we don't get to, we'll endeavour to answer directly via email afterwards. So the full report is now available on the GSA website. We'll share a link with that to that with you immediately after the event. But to kick things off, I'll first hand over to the GSA President, Joe Barrett, to introduce things. Okay.
Thank you, Richard. So welcome everybody to this webinar, which we try and do every 4 to 6 weeks. Main thing about, if you don't know about GSA, we are the industry voice of the global mobile ecosystem, representing the 9 major suppliers in the industry and others as well as part of our membership. And we have an associate subscription service that allows companies that don't want to be members and are not suppliers to get access to all our data, member reports, and also our Gambod industry databases, which cover a wide range of topics from devices to spectrum assignments, public and private networks, chipsets, and operators. So a lot of experience and information has been provided into those databases. And we have a number of working groups, including the Fixed Wireless Access Forum, which has now over 55 participating companies. A private mobile networks group, and a new RedCap group, which we're just kicking off and working on what that group will look to deliver. So again, we have more than 160 annual reports that are available. Many of them are free as a summary, and then also access for member reports that give far more detail on what's happening in the industry. So with that, I'll pass over to Jordan, who's heading this area of the GSA research. Jordan.
Perfect. Thank you very much, Joe, and good afternoon, everybody. As Joe mentioned, I'm Jordan Cox, a member of the research team here at the GSA, and I'm responsible for coordinating a number of the research projects the GSA undertakes, alongside populating our online database, Gambod. So in this session, I'll be sharing some key insights from the GSA's latest report, 5G Advanced Global Status Update, with data current as of the end of April 2025. And we'll start with a global snapshot of where things stand today, focusing not just on 5G Advanced, but also on the wider rollout of 5G Standalone, which is a crucial enabler for many of the advanced features coming with this next evolution of 5G. And from there, we'll look at what 5G Advanced actually brings to the table, what makes it different and why it matters. We'll then dive into the current state of the ecosystem, including progress across chipsets and devices, as these developments are key to understanding how close we are to commercial reality. So across the next 15 minutes, we'll unpack where we are, where the market is heading, and how 5G Advanced is positioned to unlock the next wave of 5G innovation, not just in performance, but in capabilities that align with both consumer and industrial needs. So let's start with a quick overview of what we mean by 5G Advanced. So think of it as a midpoint between today's 5G and tomorrow's 6G. It's part of 3GPP Release 18 and beyond, building on the foundation of 5G standalone networks, but introducing a wave of new enhancements. So in simple terms, 5G Advanced boosts the performance, efficiency, and intelligence of mobile networks. It's about faster speeds, lower latency, and better spectrum use. But it's also about new capabilities. This includes being more AI native. Artificial intelligence and machine learning are built into the network architecture to support smarter decision-making, automation, and optimization. It's also XR ready, meaning it supports the growing needs of extended reality, everything from augmented reality apps to industrial-grade virtual training tools. And one of the major shifts with 5G Advanced is its ability to expand 5G into new sectors. So think smart factories, connected mining, advanced logistics, and energy grid management. It's a step toward real industrial transformation. So finally, 5G Advanced helps deliver smarter, greener networks with more efficient energy use and intelligent resource allocation. It supports operators in hitting sustainability targets whilst improving overall network performance. So this isn't just an incremental upgrade. It's a step change that lays the groundwork for the next generation of wireless connectivity. So before we go deeper into 5G Advanced, it's important to understand the role of 5G Standalone. 5G Standalone is not just a technical upgrade, it's a fundamental requirement for 5G Advanced. You cannot build a 5G Advanced network on top of a non-standalone 5G core. So for any operator looking ahead to 5G Advanced, deploying Standalone is the first step. And this slide shows the current global status. And according to the GSA data, as of the end of April 2025, there are 163 operators across 65 countries globally that are currently investing in 5G Standalone. And out of those, 73 operators in 40 countries have already launched commercial 5G Standalone networks. And what you see here is a clear upward trend. More and more operators are investing in this foundational technology, and the pace of commercial launches is very much accelerating. And this expansion of 5G Standalone coverage is what enables the next wave of innovation, whether that's intelligent network management, ultra-reliable low-latency communications, or support for industrial IoT at scale. And so in short, no 5G Advanced without 5G Standalone. Operators who've already made that move are now well positioned to begin testing and deploying 5G Advanced features. So 5G Advanced isn't just a modest update, it's a significant step forward with broad benefits across the network, the user experience, and entirely new use cases. So let's start with the most immediate impact, enhanced mobile broadband, known as the eMBB+. This boosts performance in busy environments like stadiums or city centres. It delivers faster, more consistent download speeds, better uplink performance, and more efficient use of spectrum. So that means smoother streaming, quicker downloads, and more responsive apps, even in crowded conditions. Next, we have enhanced energy efficiency. 5G Advanced introduces advanced power saving features, including sleep modes that temporarily shut down unused network components. This makes it a greener, more cost-efficient technology, particularly important as networks scale and energy costs rise. And then there's advanced positioning. 5G Advanced can achieve centimeter level accuracy, even indoors. And this is a major upgrade over what previous mobile generations could offer. It has real-world applications in everything from warehouse robotics and autonomous vehicles to emergency services, AR navigation, and asset tracking in logistics. We are also seeing support for non-terrestrial networks, or NTN. 5G Advanced is the first generation to natively integrate satellite connectivity, enabling coverage in areas traditional infrastructure cannot reach, such as mountains, oceans, rural regions, or even for disaster recovery scenarios. This opens the door for more reliable global connectivity for aviation, maritime, and remote users. And a powerful improvement comes in device-to-device and side-link communication. And this is key for safety-critical applications like vehicle-to-everything, or V2X, vehicles and drones can communicate directly with one another now, even outside the range of cellular towers. And that means faster, safer coordination in transport, logistics, and again, public safety. And 5G Advanced also introduces smarter AI native network capabilities. And machine learning can now be used for traffic management, predictive maintenance, and real-time network optimization. It also enables more precise network slicing, so industries like manufacturing, healthcare, or media can have highly tailored, reliable connectivity. And finally, it enhances support for massive IoT and ultra-reliable low-latency communications. And this allows for millions of connected devices, from smart meters to surgical robots, to operate simultaneously with high reliability and low delay. And so taken together, these benefits show why 5G Advanced is so important. It's not just about speed, it's about scale, intelligence, energy efficiency, and opening up new opportunities across every sector. So we've seen that 5G Advanced brings major technical benefits, but what about real-world momentum? So according to the GSA's latest data, 5G Advanced is moving at pace. We've identified 26 operators across 15 countries that are already investing in this next generation technology. And right now, most of these investments are in the form of tests and trials, which is typical for a technology at this stage. The GSA tracks 14 operators who are actively testing 5G Advanced capabilities, and these range from lab-based evaluations to field trials in real-world environments. But this isn't just experimentation for the future. Some operators are already moving into commercial deployment, and as of April 2025, we've recorded 6 operators that have launched 5G Advanced networks. That's a clear sign that the market is shifting from concept to execution. And the current pace also reflects a broader shift in how quickly mobile technologies are evolving. With 5G standalone deployments maturing, operators are now well positioned to move into 5G Advanced and tap into its benefits. Not just for speed and performance, but also for enabling more advanced services, smarter network management, and new revenue streams. And so whilst 5G Advanced is still in its early stage in its life cycle, it's rapidly gathering momentum. And we expect to see many more commercial launches in the coming 12 to 18 months. So when we look at regional momentum for 5G Advanced, it's clear that Asia is very much leading the way currently. We are seeing the highest levels of investment activity across this region, with countries like India, Uzbekistan, and Taiwan conducting trials and planning deployments. And most notably, both China and Macau have already moved ahead with commercial launches of 5G Advanced. Now, this isn't entirely surprising. Asia has historically been a leader in mobile innovation, and countries like China have national strategies that prioritize rapid digital transformation, smart cities, and industrial automation, all of which benefit from 5G Advanced capabilities. Whereas in contrast, Northern America and Latin America are seeing much slower adoption at this stage, with GSA data showing that only one country in each region, namely the United States in North America and Brazil in Latin America, currently investing in the technology. However, it should be noted that T-Mobile in the United States has launched 5G Advanced technology. Europe, meanwhile, sits somewhere in between both of those regions. We've tracked 5G Advanced investment in activity in Turkey and Finland, but compared to Asia, it's still relatively early days. And these regional differences could reflect several factors, from spectrum availability and regulatory environments to operator readiness and broader economic priorities. But what is clear is that Asia is setting the pace. And if this trend continues, we may see an early technological edge emerge across Asian markets as 5G Advanced becomes more commercially widespread. So let's now take a look at the devices and chipsets enabling the 5G Advanced ecosystem, starting with modems that support 3GPP Release 18, which is the technical foundation of 5G Advanced. The Qualcomm Snapdragon X72, X75, X80, and the upcoming X85 are among the most high-profile modems to support Release 18 features. And these are designed to deliver improvements in power, efficiency, uplink speeds, location accuracy, and latency, which are all core goals of 5G Advanced. The Snapdragon X75, for instance, integrates an AI processor that supports real-time beam management and network optimization, helping devices adapt more intelligently to their surroundings. It also enables 5G NR Lite or RedCap, allowing smaller, more efficient devices like wearables or industrial sensors to benefit from 5G. And we also have the M90 5G modem, developed by MediaTek. It supports advanced features such as carrier aggregation, dual connectivity, and high efficiency MIMO, which are essential for the enhanced mobile broadband and low latency performance promised by 5G Advanced. And these modems are not just about faster downloads. They underpin use cases like extended reality, smart manufacturing, and vehicle to everything or V2X communication. And as chipset vendors accelerate their roadmap toward Release 18 and beyond, we are likely to see even more energy efficient, intelligent, and versatile modem designs coming to market over the next few years. And so ultimately, chipset evolution is a key indicator of how close we are to commercial readiness. And what we are seeing here suggests that the ecosystem is moving quickly towards supporting 5G Advanced at scale. So now let's turn our attention to the device ecosystem, a key enabler of 5G Advanced adoption. And we are beginning to see major OEMs introduce smartphones that support 3GPP Release 18. The foundation of 5G Advanced, for example, Samsung's Galaxy S25 series, including the base model, S25 Plus and S25 Ultra, is expected to support key 5G Advanced features such as enhanced uplink, improved spectral efficiency, and smarter network interactions. And these improvements will contribute to better real-world performance in dense urban settings and power-sensitive environments. And meanwhile, Xiaomi's 15 series, the Xiaomi 15, 15 Pro, and 15 Ultra also support Release 18. And Xiaomi has been an early adopter of 5G innovations and is positioning these models for high-performance use cases, including advanced mobile gaming, real-time translation, and AR applications, all of which benefit from lower latency and more reliable network behavior enabled by 5G Advanced. And so these devices are not only showcasing early hardware readiness, but they also signal growing industrial alignment toward making 5G Advanced a consumer reality. And as software updates roll out to support new 5G Advanced features, users will see tangible improvements, particularly in upload speeds, battery life optimization through more efficient modem operation, and smarter handover between network types. And so in short, we are seeing the ecosystem shift from theory to implementation, and these commercial devices are an important indicator that 5G Advanced is ready to scale. And another major advancement in 5G Advanced is the enhanced support for non-terrestrial networks, or NTN, especially satellite integration. 3GPP Release 18 includes new specifications that improve interoperability between terrestrial and satellite networks, building upon earlier groundwork laid in Release 17. And this is significant because it lays the foundation for a more seamless and global 5G experience, especially in hard-to-reach areas. So, for example, imagine a connected device switching from a terrestrial base station to a satellite link, and for instance, on a cargo ship or in a rural village, without interruption or degradation of service. And that's the promise of standardized NTN, and it's a game changer for industries like maritime, aviation, and emergency response. And momentum in this space is building. The GSA has tracked 61 partnerships between mobile operators and satellite vendors across 40 countries, focusing specifically on satellite to cell phone services. And this is a huge leap forward in just a few years. And out of these, 21 partnerships are currently actively testing the services, 31 are planning deployments, and 9 have already launched commercial satellite to cell services. And whilst not all of these partnerships are currently aligned with 3GPP Release 18, the convergence of standards is well underway. As more operators commit to NTN investments and as chipset support improves, we are likely to see wider scale rollout and tighter integration of satellites into the global 5G infrastructure. And so this step toward truly global coverage is a defining feature of 5G Advanced. And it underscores how the technology is expanding beyond urban centres and traditional infrastructure to meet users wherever they are. And so to close, let's take a step back and look at the broader picture from the GSA's perspective. 5G Advanced represents a major evolution of 5G, unlocking entirely new capabilities that go far beyond speed improvements, with AI native architecture, centimeter level positioning, and support for extended reality and industrial grade IoT. This technology is tailor-made for the next generation of applications. And it delivers not only a better user experience, but also enhances operator value, especially through uplink performance gains, low latency, and network automation. And this is particularly relevant as data demand shifts more toward creation. So think video uploads, remote collaboration, and real-time industrial data. And these capabilities enable transformative use cases, from autonomous vehicles and precision logistics to smart cities with intelligent infrastructure and dedicated private 5G networks for sectors like manufacturing, healthcare, and utilities. And as we've seen in today's data, ecosystem momentum is already underway. Modems and chipsets supporting 3GPP Release 18 are here, and flagship devices are launching with compatibility, and early tests and trials by operators are laying the groundwork for commercial deployments in 2025 and beyond. And so in short, 5G Advanced is not just another upgrade, it's a critical stepping stone to 6G. It prepares the industry and the infrastructure for the future, whilst delivering real world value today. And that the GSA will continue tracking the evolution of this ecosystem closely, and we do expect to see accelerated progress over the next 12 to 18 months. As trials mature, standards consolidate, and global launches ramp up. So that brings me to the end of the presentation section of this webinar. We'll move to the Q&A section, and my colleague Ian Fogg is answering questions in the behind the scenes, but I'll go through a few here. So we've got questions on what are the benefits of 5G Advanced for fixed wireless access in particular. So there's quite a few benefits to fixed wireless access. So for example, there are network slicing improvements that will help fixed wireless access. And we have seen quite a few examples where operators put fixed wireless access traffic on a separate slice. And there are also energy saving enhancements that will benefit fixed wireless access in particular. So fixed wireless access is going to see quite a large range of improvements and benefits from 5G Advanced. Let's have a look at some of these other questions. So there's a question here on, are there any network vendor deployed advanced positioning capabilities? Also, what is the status on URLLC and is that picking up? So the URLLC needs the 5G core and 5G standalone as well. And as can be seen in the data, we do have momentum on standalone, and that is picking up pretty dramatically, especially over the last sort of year to year and a half. But many of those standalone launches are very recent, especially at the start of this year. We have seen a lot of activity, and URLLC in this area is an area we do expect to see grow as operators build on those 5G standalone foundations. But it's worth noting, as I mentioned, that 5G standalone launches are still recent and it is still moving, but it is still very much in its early stages itself. So let's have a look at some more questions. They're coming in pretty quickly. Okay, so there's a question on devices. So do devices that are compatible with 3GPP Release 18 support connection to satellites or NTN? So 3GPP NTN support started in Release 17 a few years ago. There are further enhancements in Release 18 that I've pointed out here. But precise compatibility for a given device very much depends on the hardware implementation, specifically what bands are supported by a device, and so on. So that's an interesting question there. I'm just trying to get through some of these questions as they're coming in, so just bear with me as I'm reading through. Okay, so there's a question on the biggest challenges operators face in deploying 5G Advanced, which is obviously a very important point. And the main hurdles, firstly, include upgrading to 5G standalone. Obviously, that's going to take investment, significant investment, but that is very much important as a prerequisite to 5G Advanced. But also integrating new hardware like AI native modems and justifying the investment in regions where current 5G is still not rolling out, which there are many regions across the world where that is happening. But there's also the skills gap around managing more intelligent software-defined networks. So there are a few challenges when trying to deploy 5G Advanced. 5G standalone is the vital aspect of all of that. Okay, let's have a look at some more questions. Okay, here's an interesting one around private networks. So how are private networks expected to benefit from 5G Advanced? So private networks can leverage advanced features like enhanced positioning, deterministic latency, and integrated satellite fallback. And these upgrades are especially relevant for the verticals such as manufacturing, energy, and logistics. And the GSA does track private mobile networks. Figures on the top of my head, we have tracked around 101 private network customers worldwide that are utilizing 5G Advanced. So that, there is a lot of movement in that area, and private networks are really going to benefit from this. Okay, let's have a look at some more questions coming through. We've got a bit of time for a few more questions. Okay, so how does 5G Advanced affect spectrum use or spectrum efficiency? Obviously, I mentioned that a few times in the presentation there around spectrum efficiency, and it's a really important point. So 5G Advanced improves spectral efficiency through, firstly, better MIMO management, but also dynamic spectrum sharing, and of course, AI-enhanced traffic steering. All helps to really make that spectral efficiency increase. And, this really helps operators squeeze more value out of their existing spectrum assets, which of course is always very, very important for ROI perspectives. Okay, let's have a look at a couple more questions. Okay, so around regulators now. So again, another important area. So it's a really good question. So are regulators taking any steps to encourage or standardize 5G Advanced rollouts? Currently, not directly as of yet, but some regions are updating spectrum licensing rules and promoting NTN integration, which does support 5G Advanced indirectly, but formal regulatory focus will likely increase as commercial launches ramp up, especially across the rest of this year and into 2026 and probably 2027 as well, and moving towards the end of this decade. So yeah, really important that regulators do start taking those steps to encourage and standardize to really boost that 5G Advanced ecosystem. Okay, we've probably got time for one more question, and we will answer any leftover questions that we haven't got to after the webinar. Okay, let's have a look. Okay, so here we have, so could 5G Advanced eventually reduce the need for fiber backhaul in rural areas? Potentially. The combination of enhanced uplink, satellite integration again, and more efficient spectrum use may allow operators to offer fiber-like performance. wirelessly, especially in areas that are underserved or remote. So yeah, absolutely. But it's only potential. So we'll see how that plays out as we move forward. So yeah, there's a lot of questions there and there's still a lot to go through. So we will be replying to those after the webinar, but that probably brings us to the end of this session. I'll hand back to Richard to close us out. Thank you very much.
Great, thank you, Jordan. And again, thank you for all your questions. So any that we haven't answered yet, we'll certainly endeavour to answer offline in the coming days. So I'll just close by thanking you for joining us and thanking Jordan for the presentation and Ian for all the Q&A work in the background. After the event, you will receive a link to the webinar recording, the presentation, and to the full report. You can see we've got a full calendar of events running throughout the year. We'll be releasing more information on these events nearer the time, so please do keep an eye on the webinar page. You'll also see full back catalogue of recent webinars with on-demand replays as well. So if you're interested in the recent RedCap event or 5G standalone, any of those sorts of topics, you'll find recent webinars on those there. All the data behind the report that Jordan has gone through today is available to all employees of GSA members and associates. If you'd like more information on how your organisation, how you yourself can get access to all this data, please do get in touch. So if your organisation is a member, then every employee has access. You just have to use your work email address and you can log into Gambod right away. All the latest updates on GSA research activities and events on the website and on our social channels. Please do register for our monthly newsletter and email updates so you get the latest alerts on new reports delivered straight to your inbox. So finally, I'll just close by saying on behalf of the GSA team, thank you again for joining us, and we hope to see you at one of our future events in the coming weeks. Many thanks.